Hello, my name is Himanshu, and today we are going to start the chapter linear algebra. And the subtopic is, I choose the subtopic is linear transformation. So, by the reference of the competitive exam IIT JAM, that is, so IIT JAM is the entrance exam for MSc to get admission in IISER, NIT or IIT. Okay. to get admission in MSc. Okay, so I choose the topic linear transformation. So the question is, so what is linear transformation? Okay. So let's let's suppose we have a 1 minute. Okay, so let's suppose we have a space that is R2 space. Okay, so we are going to choose that is R2 is a vector space. Okay, so firstly R2 is a vector space. So R2, this is our R2, this is our X and this is our Y. So these are R2 space. These are R2 plane, or we are going to say XY plane or Euclidean plane. Okay. Like a flat surface. So we are going to say these are R2 is a vector space, and the property that satisfies the vector space is vector addition and closure property. Okay, so some have a property. So now we have a one vector, like say V. Let V be a vector in R2. So let's suppose this is our vector V R2, and this have a two component. Okay. So V is equal to V1 and V2 belong to R2. So suppose we are going to define some kind of mapping. Okay, we are going to define some kind of mapping, and let we define a mapping. We define a mapping from R2 to R2 space. So from now, firstly we are going to see, we are define a so we are going to define a mapping from same space to same space. Okay, after some time we are going to see we can define a mapping from one space to the another space. Okay, not as a same space. So we define a mapping defined by a space, define a mapping by T. Okay, so this is our, when we define another mapping, so this vector under some kind of mapping. Okay, under some kind of mapping, let's suppose this is our T. Under some kind of mapping, this vector will look like this. This is our T of alpha V. Okay, so what does that mean? If first V1 and U V are two vector, let's suppose these are U V are two vector in R2, and if T U plus V, if we add one vector to the another vector and then we can do a mapping, then it will give a tu plus tv. It means that this is a some kind of tu and this is our tu and tv. Okay, the second thing is when we are going to do a scalar multiple. Okay, let's suppose alpha belong to R or alpha belong to a field R and alpha times u also belong to R2. So T of alpha u is a scaled vector is also a mapping by a scaled mapping. Okay, that means T of alpha u is equal to alpha times T. These are two property to become a linear mapping. Okay, now we are going to use the term what is the meaning of the transformation. Okay, so firstly the another more properties, T0 is equal to T0. It means that the zero vector is mapping to the zero vector, or by the C the geometrically zero vector is always mapping or always mapping through the origin. Okay, so that is the main motive idea. Okay, now we are going to use the term transformation. See, the transformation is the transformation is linear mapping, linear mapping from same vector space to same vector space. That means V into V. Okay, let's say example we have a T such that R2 to R2. So this is a definition of, not a definition, we can say that this is a linear transformation and this mapping will satisfy these three conditions. Then we can say that this is a linear transformation. This condition satisfy above three conditions, then we can say it is linear transformation. Okay, so now we are going to use some example when we are going to say it is not a linear, so it is not linear transformation. When we are going to say, okay, so let's suppose we have example T. Let suppose we have example T R2 to R2 by T x y is equal to, see, two-dimensional vector is mapping to a two-dimensional vector. Okay, so we are going to take x plus 1 and the second tuple is x plus 3. Okay, so everything is fine. So here see, we do not need to find all these things. We are only just to see is this vector, is this transformation mapping is passing through the origin or not. So we can clearly see this does not passing through the origin. Okay, see the 0 vector is not passing through the origin. See, it is a 1 3. So obviously it's not a linear transformation, and also you can see if you can get any scalar multiple of this, you cannot get equal to this RHS. So it is not a linear transformation. Okay. So now we are going to see the so these are okay. Now we are going to do a 2 example. One example is from we are going to see any linear transformation is a linear transformation, and another part is we are going to see one example or question from IIT JAM of the year 2025. Okay, so the first is, so the question is so the question is, let T V to R. Obviously here it is V a vector space and R is a scalar field. Okay, so it is mapping, we can define as some mapping, that is mapping from a vector to a scalar field defined by T of fx is equal to integral of 0 to 1 ft dt. Okay, now it is fine. 1 minute, I do a mistake, it's not a ft, fx, it's a ft. Okay, so note, if any mapping from vector space to field, say R, those mapping called functional, and here it is a linear functional. Okay, so those mapping are called functional. That is the part of functional analysis, and these are most famous example. Anyway, so it is a vector space or not. So T define V to R by T of ft, and obviously F belong to the vector space V. Okay, so it is 0 to 1 ft dt. Let f1 f2 belong to V. So firstly we are going to see the transformation. So the transformation T, this mapping is a linear transformation. Firstly we are going to see these 3 property, it is satisfied or not. Okay, so T f1 plus f2 T is equal to 0 say 1 integral f1 plus f2 T dt. 0 to 1 f1 T dt. Why we are going to write? Because we know integral property will also satisfy the linear property. Okay, integration is also satisfied linear property. Okay, 0 to 1 f2 dt is equal to, these are f t f1 plus t f2. Okay, so first condition is satisfied. Second, let alpha belong to field R. Okay, so alpha f also belong to, must have to belong to V. Okay, otherwise it can't be happen. So t of alpha f is equal to integral 0 1 alpha f t dt is equal to alpha integral 1 f t dt. So these are nothing but it's a t of f. It is alpha t of f. Okay, second property also satisfied. Okay, the second property is also satisfied, and the third property, t0 is equal to 0 से 1 0 dt, it is equal to 0. Okay, so therefore t, mapping t is linear transformation, and also called, it is linear functional. It is also called a linear functional. Okay, so we are going to see the next question is, that is asked in the exam IIT JAM 2025 of the of mathematics. Okay, so wait for 1 minute, I have to see, I have to write. So next question, IIT JAM 2025, question number 6. So question number 6, it says that define T R3 to R3 is a one kind of linear transformation mapping, and it is defined by T x y z is equal to x plus z, 2x plus 3y plus 5z, 2y plus 5z for all x y z belong to R3. So the question is, which of the following is true? It says that in this question, this linear transformation is a 1-1 onto or a bijective. Okay, so how we can deal with these things? So I have some technique. So question is, wait, I have to T R3 to R3 defined by T x y z. This from IIT JAM 2025 paper, this year paper of question number 6. Okay, so it is x plus z, another is 2x plus 3y plus 5z, 2y plus 2z. Okay, 2x 3y 5z. Okay, so now the question, it says that it is 1 or onto. So solution, let be 1 0 0 0 1 0 0 0 1 are basis of R3. It is a standard basis of R3, and by this basis we are going to find the linear transformation. Okay, and also we are going to find the matrix representation. Okay, and size of this matrix is 3 by 3 matrix. So T1 0 0 is going to be a 1 plus z 1 2x plus this is going to be a 1, and another is 0. So it is a 1 times 1 0 0 plus 1 times 0 0 1 1 0 plus 1 times 0 0 1 T0 1 0. It is x plus z 0 2x plus 3y plus 5z and 2y plus 2z. So it is 0 1 0 0 plus 5 0 1 0 plus 2 0 0 1 0 0 1 x plus z, it is 1 2x plus 3y plus 5z 2y plus 2z. It is equal to 1 times 1 0 0 5 times 0 0 plus 2 times 0 0 1. Okay, so now our matrix is 1 1 0 0 5 2 1 5 2. Okay, 1 0 0 0 5 1 minute. T 0 1 0. So x plus z 2x plus 3y plus 5z. Okay, 2y plus 2z. Okay, that is okay. X plus z. So x plus z is 1 2x plus 3y plus 5z 1 2y 2y plus 2z, that is 1. Okay, so where I am going to wrong? 5 5 0 2 2 1 0 0 0 5 5 0 0 0. Okay, so see, determinant of t is equal to 0. It means that t is not bijective. Okay, so therefore t is not 1 1, not onto. Therefore option D will be correct. Okay, so thank you.